motion. We say an object moves if an object is changing its position. Let's say at time 2 seconds, a person is at one position, and after time elapses, maybe after another second, if you see, then the person changes his position, then we say that the person has moved from one place to other place. So that is, if an object is at one point in space at one instant of time and at a different point in space at a different instant of time, then we say that the person or the object is in motion. So we measure how fast an object is moving from one place to other place, and that is measured, or that is classified as a physical term, speed. The speed of a moving object is the rate at which it covers the distance. The speed's formula is speed equals to distance over time. So if you are taking longer time to cover a distance, it means you are going slow. If you are taking smaller time to cover certain distance, then it means your speed is high. For example, if you are covering 60 miles in 2 hours, then your speed would be 30 miles an hour. At the same time, if you are covering 24 miles in half an hour, your speed would be 48 miles an hour. The average speed is the total distance traveled by an object divided by the time taken to travel the whole distance. Let's say if you are going from school to home or home to school, you will have different speed limits. So if you want to find out what is the average speed you have driven to go from school to home, then you add all the whole distance from your school to home and the whole time you have taken to cover the distance. You divide it, then you get the average speed to go from school to home. The instantaneous speed. Instantaneous speed is an object's speed at a given instant of time. Something like the police using his radar to find out the speed at that particular second. So something like that is an instantaneous speed. At that particular time, what speed it is. If you're looking at a graph in which if you have equal spacing dots, it means the glider is moving at a constant speed. The variables are v is equals to t over t, and v is speed, d is distance, t is time. We can solve for distance by shuffling the variables around, and that will give you d is equals to v times t. So if you take this t from here, this is in the denominator, so it will go to the numerator. So if you want to find out the value of d, that would be nothing but v times t, that is velocity times time, or the speed times time gives you the distance. So let's do one example. How far does a car travel in 6 hours at a speed of 40 miles an hour? So in this problem, we have the time given as 6 hours and the speed as 40 miles an hour. So you want to find out the distance covered. So that's going to be distance is equal to v times t. So v is given as 40 miles an hour. Time is 6 hours. So hours cancel. So 40 times 6, which will be 240, and miles is the unit. So the car will be traveling 240 miles with speed of 40 miles an hour for 6 hours. So here is the picture representation. If the person starts at 0 and if he uses 40 miles an hour, then if he takes 6 hours, then the total distance would be 240 miles. We can also solve this for time. So we have d is equals to vt, and if you want to find out the time, then it would be the velocities in the multiplication. So if you bring it down this side, that will go to division. So time would be d divided by v. So if you want to find out time, that would be d divided by v. How long does it take it to travel 100 miles at 40 miles an hour speed? So in this case, we have the distance given and we have the velocity speed given. So we need to find out how long, which is time. So we already know the time is nothing but d over v. So distance is 100 miles. The speed is 40 miles an hour. So if you do the math, then you get 2.5 hours as your time. We have another interesting example here. Let's say you are standing 100 meters north of your car when you see an alligator appearing 50 meters north of you, and it begins to run towards you at 8 meters a second. At the same moment, you start running towards your car 5 meters a second. Will you reach the car before an alligator catches you? So let's look at this picture right here. So your car is right here and you are standing 100 meters north of your car. And an alligator was 20 meters away from you. As soon as the alligator saw you, it started running towards you at a speed of 8 meters a second. That is quite fast. Then you started running at a 5 meters per second to go to your car. Let's say that if you're fast, and since you have a shorter distance to cover, if you're fast enough, you can reach the car, then you'll be safe. If the alligator is going to take less time than you, then it means it's going to stop you somewhere in the middle and attack you. Then you won't survive. So let's see who will reach first. So let's see from here, how much is the distance the person has to cover to go to car? 100 meters. Now let's find, and this person is going at a speed of 5 meters per second. Now look at the distance for alligator to car. How long the alligator has to travel from car to till car? That's going to be 20 from here to here and 100 from here to here. So altogether 120 meters. And the alligator is going at a speed of 8 meters a second. So let's plug in those things here and try to find out the time the person takes times the alligator takes. So now you can see that the person takes 20 seconds to go to the car. At the same time, alligator would have taken only 15 seconds to go to the car. It means it would have caught you somewhere in the middle and attacked you. Sorry, this is your last calculations. You are the alligator's lunch. Vectors. There are two types of physical quantities, scalar quantities and vector quantities. Scalar quantities have magnitude only as such as time, mass, speed, etc., which has no direction. So these things, no, doesn't matter which direction we go, we are worried about only the value of it, which is the magnitude of it. And vector quantities, we are concerned about their values as well as which direction they are going in. Those are called vector quantities. The examples are velocity, acceleration, force, momentum, etc. A vector can be represented by an arrowhead line whose length is proportional to the magnitude of some quantity and whose direction is that of the quantity. So this is how you represent, and the length of it would be the magnitude of that vector. Adding vectors. We have to account for the magnitude and the direction when we are adding the vectors. Graphically, we place the tail of one vector at the point head of second vector. So it is something like this. So if you are adding two vectors, then instead of going this way, the arrow goes this way. The C will be the resultant vector of A and B. So let's look at the Pythagorean theorem. So Pythagorean theorem is applicable for the right angle triangles, in which if you know two sides, you can find out the third one, and that is this is called the hypotenuse. If you know this and this, you can find out the value of c, which is the hypotenuse. So a square plus b square gives you the value of c square. So using the Pythagorean theorem, we want to find out the displacement of a car that goes 5 meters north and then 3 meters east. So you want to find out how much is the distance between its ending point to the starting point. The starting point, ending point, this is the shortest distance. So you want to find out the value of c. Since c is equals c square equals to a square plus b square, that gives you 3 square plus 5 square gives you 25 plus 9, that's going to be 34, and you want to find out c, so that's going to give you square root of 34, that's going to be 5.83. Acceleration. The acceleration of an object is the rate of change of its velocity and is a vector quantity. So acceleration is the how fast an object is moving. Okay, so what the rate of change of the velocity is a velocity, and it's a vector quantity. So for a straight line motion, average acceleration is the rate of change of speed. So you use this formula, which is a is equals to vf minus vi divided by t. So a is the acceleration, vf is the final velocity, vi is the initial velocity, e is the time, t is the time taken to have the transition. Or you could always write it like v2 minus v1 divided by t. So let's say that if the car is in cruise mode, it means the velocity it started with will be same. If we are keeping it for like an hour cruise, then the final velocity will be zero. Final velocity will be same too. So the change in the speed is not there. So the acceleration will be a zero. So look at these three cases of acceleration. In the first case, you can see that the car is picking up the speed. It started with slow. Now it pushed gas. So it means the initial velocity is lower than the final velocity. So you get a positive number in the numerator. So your acceleration is a positive acceleration. In the second case right here, you were going at a high speed and you slowed down and came to complete stop, or maybe you are slowing down much lower. So you can see that it started with high speed and now it's going with the lower speed. So the difference in final velocity to initial velocity will be a negative number. So you get a negative value for acceleration. In the third case, you can see that the acceleration, the speed is maintained constant. So you can see that it is occupying the same distance in equal intervals. So you can say that there is no change in the velocity. So the v final minus v initial will be a 0. So the acceleration will be a 0. So from here you can say that the acceleration could be a positive, negative, or 0. Let's look at an example. A car accelerates from 15 meters per second to 25 meters per second in 20 seconds. What is the acceleration? So you can calculate the acceleration by substituting the final and initial velocities with the time. That's going to be 25 minus 15 over 20. That gives you the acceleration of 0.5 meters per second square.